Now the topic is digital time and period measurements. We know that F equal to 1 by T and then T equal to 1 by F. What is frequency? Frequency equal to cycles per second. Similarly, what is time period? That is inverse of frequency. Therefore, time period measurement or a time measurement is seconds per cycles. This is the basic concept. We know that F equal to 1 by T, T equal to 1 by F. The digital time and period measurement. The digital time and period measurement circuits are similar to that of a frequency measurement. So this circuit diagram is also similar to that of digital frequency counter, but there is a small difference is there. The presence of gate control is very important. Gate control FF, I mean flip-flop gate control, is present in the input signal whose time period is measured. See the diagram. Here in the previous case, I mean digital frequency counter, this gate FF, flip-flop gate control is present in here, I mean time based selector. But here in case of time measurement or period measurement, this gate control is present in the input side. That is the one and only difference between the digital frequency counter or measurement and digital time period measurement. Okay, the block diagram of a time measurement is shown in figure. It is necessary to measure the time period rather than frequency. Similar to that frequency counter, this circuit are also consisting of main gate, I mean this one, main gate control FF, this one, and time based selector. This one is a time based selector. The gate control FF has a start and stop input which is derived from the input signal whose time period is to be measured. This one, gate control FF or flip-flop gate control, that it is having a start and stop signal, that it is from a input to be measured. The output of the gate control FF fed to one input of the main gate. Here, this is one of the main gate. Another input of the main gate is fed by a time based selector. This one is fed by time based selector. The time base consisting of a crystal oscillator for a fixed frequency. To ensure the accuracy, it is enclosed in a constant temperature oven, because this is the crystal. To maintain a constant frequency, it should be maintained at a constant temperature. Okay. Output of the oscillator is fed to a Schmitt trigger, where the sinusoidal signal is converted to a square pulse. This is the crystal oscillator that will be fed to a Schmitt trigger, that it converts the sinusoidal to square. Then the train of pulse is fed to a 6 number of decade assemblies connected cascade as shown in the figure. To get a specified time, we are having a divided by 10. This one having a 1 microsecond, again that it is divided by, so we can get a 10 microsecond, then divided by 10, 100 microsecond, it goes up to 1 second. Okay. The 6 decade frequency device provide a time based range from 1 second to 1 microsecond to 1 second, conveniently selected by the selector switch. The oscillator runs continuously. It is fed to a one input of the main gate. Start pulse of the gate control FF is provided by input 1 and the stop pulse is provided by the input 2. Start is provided by input 1. This is input 2 that will provide to stop gate pulse. By combined input of the gate control FF and a time based selector in main and gate, the number of output pulses counted based upon this input start. If you give a start pulse, this will be high. Then time base will be high, means it will count the output of the AND gate. Finally, it's also measured by a time period of a signal. For example, we can also, frequency is also measured, because very first I told F equal to 1 by T or T equal to 1 by F. Okay, by making calculation we can get the frequency also. And then one more important point, If you want to get a high score or more marks to get high score, if you want to write more means, you can include the gate control circuit with elaborate. You can write the theory also here. Okay, thank you.